what was this? Was 56, yes. Okay, let's look at okay, 58. And that is x squared plus y squared. And then plus 12x minus 6y minus 4 equals 0. Is this the equation of the circle? The answer is I have no clue. As long as I can present it like this, it will be. Otherwise, it's not. If this, for example, turns out to be 0 or a negative number, that's not the equation of a circle. If I have a 3 in here or a negative, that's not the equation of a circle. It has to be identical. 1 x minus something squared, or even 0 but squared, plus 1 y minus k squared equals a positive number. Good. So look at x squared and 12x and say you have to add so what do I have to add?
4.
Say it again.
4.
So 12 divided by 2 is 6. 6 squared is 36. So now this and this and this are what? Right, what you squared to get 36. That has to be. And then plus. What do you think about y squared and negative 6y? Yes, a 9. So now this and this and this.
Minus 3.
So now again, this, and this. Yes.
How can we do square 6? How can we then do 6y? And I got where you got 2. I mean 12. 12 divided by 2 is 6.
Negative 6 divided by 2 is negative 3, and negative 3 squared is 9.
Oh, that's what we got to know.
That's what we have to add.
Okay.
And the right-hand side again is 49. It happened. So what is the center and what is the radius?
6, 3, 7.
Good. Remember, without practice, I know you understood it, but without practice, it will go away very fast. So this completes chapter 2, so we are ready to start chapter 3.
So if x or y ever have a coefficient in there, it's not a circle.
Yes, it's not. It's either hyperbola or a ellipse or something
Not a
else.
perfect circle.
It has to be exactly that. One, some quantity with x alone, not x and y. X alone squared plus some quantity with y. It may not have the number, but it has to be y squared equals a positive number, not even 0.
So then maybe they'll just-
If it's 0, exactly. That would be a point. Right. Very good. Chapter 3. Chapter 3 is a big chapter. It deals with polynomial and rational functions. Polynomial and rational functions. In 3.1, we start by looking again at quadratic functions. If you remember from transformations, we already know how a quadratic function looks like. This is the x squared. We graphed it several times. And what will this be?
Minus x.
Minus negative x squared, correct. Good. So a quadratic function can be given to us in 2 ways. It means the same thing. I'll ask you what's the difference, but they mean the same thing. So the first one will be a x squared plus bx plus c, in which a, b, and c are real numbers, but I claim that A cannot be 0. How come? How come A cannot be 0?
That was 0 out of everything else.
If A is 0, this term disappears. Is this quadratic anymore? What type of function will this be? Linear. That's the reason why A cannot be 0. Here is another way in which, or another form in which the quadratic function can be given to us. Yes, we like H and K, but they have a totally different meaning here. We're not talking about a circle, but we like to use H and K. So can anyone tell us what is the difference between these two? So I look at this and I look at this, and I'll say to myself, ah, I know how this was obtained from here. How? By doing what? We just used it a minute ago. What did we do to this to get this shape? We just used the method on 2 examples a minute ago.
Completing the square.
Exactly. Exactly. So if you're given any quadratic function, you complete the square, it will look like this. Can I get from here, here? Of course, I will square, distribute A, and I will get that. So they really mean the same thing. So let's start with an example of the first one and see how to graph it. Okay, ready? So let's say negative x squared minus 6x minus 8. We are asked to graph f of x. And we will have to go through 7 steps. Step number 1, shape. I know how to graph a parabola. I don't know exactly how to graph this one right away, but I know how to graph a parabola. It's either this way, having a minimum, or it's this way, having a maximum. That's why I asked you from the beginning, if the leading coefficient is positive, the function will have a minimum. If the leading coefficient is negative, the function will have a maximum. So what is the leading coefficient of this function? Yes, so when a equals -1, the shape of the parabola is a maximum. This point, which is the maximum, is also called vertex. If a is a positive number, then the parabola has a minimum, also called vertex. Good, so in this case, we established that this parabola will have a maximum. In step number 2, I have to find the vertex. Anyone remembers how to find the x-coordinate of the vertex? No, that's okay. So here it is. I want to show you how to remember it. Let's suppose I have this equation. It's a quadratic equation. Please remind me. I want to use the quadratic formula. What do I write? Minus b. Very good. Very good. So here's how I would like you to remember the x-coordinate of the vertex. Is this. Anything that has nothing to do with the radical. That's the x-coordinate of the vertex. If you remember the quadratic formula, you will remember the x-coordinate of the vertex. So let's find it. Negative b over 2a. Negative. Can anyone give us b?
-6.
Very good. 2 times a. Can anyone give us 2 times a? Very good. I see how many negatives?
3.
What is the answer?
-3.
Very good. 3 negatives.
Oh,
Yeah. So the x-coordinate of the vertex is -3. How do I find the y-coordinate of the vertex? Say it again. No. I have a function. And I'm saying x is 1. Find the y.
0.
Oh, the y is -8.
The y is 0.
One more time. So I have a function, f of x. And I'm saying to you, x is 1. Find the y-coordinate of that point. What will you do?
Gotta input the 1.
Thank you. Absolutely. Thank you. So this is f of -b/2a. Of course, that's how we find the point belonging to a function. If I'm given x, I cannot fabricate y. Yeah, I have to plug it in. Agreed, everyone? Okay, perfect. So let's find f of -3. Negative in parentheses, -3 squared minus 6 in parentheses, -3 and -8. All I did was replace x by -3. Is this okay? Okay, so where do I start? -3 squared is,
-9.
careful,
9.
times -1.
-9.
I agree. -6 times -3,
18.
+18 and -8. I recommend do these two first and get -17 and +18, and this is how much?
What do you say?
18 minus 17.
Oh,
That's
1.
Good. Step number 3. At this point, let's imagine a little bit what happens here. So what is the vertex,
-3,
comma,
1.
perfect. So now I imagine the function.
It's the maximum.
Exactly. So what is the maximum value of this function?
It's 1.
Exactly, the y-coordinate, of course. The y gives us the maximum. X gives us the position of the maximum, right? Okay, so can you already tell me the range? We haven't even graphed the function, but we know the range.
Negative infinity
2,
to 1.
that's it. We know so little about this function, but we already have the graph in our mind. And we can already say or identify the range, but we haven't even graphed it. How powerful we are. Good. So the next, x-intercept, comma, if they exist. What is that? What does that mean if they exist? Let me give you the 3 possibilities for a maximum. This is the first possibility for a maximum. This is the second possibility for a maximum. And this is the third possibility for a maximum. How many x-intercepts does the first one have? None. It doesn't touch the x-axis. Perfect. How many x-intercepts does the second one have?
2.
2 distinct. Not the same, correct? What about the last one?
1.
Still 2, but they are the same. Good. Which situation is this? Because if it's this one, I don't want to waste my time. I will not find any solutions. If it's this one, the y-coordinate should be
0.
0, and it's not, right? So then which one is it? Is it the middle one? You already gave me the range.
Yeah.
It is the middle one. You already told me that it goes from -infinity to 1. It cannot jump over the x-axis. Does it cross the x-axis or not? It must. So they exist, so let's find them. How do I find the x-intercepts for any function?
And you gotta finish the quadratic equation.
Correct, but what do I have to write? You're on the right track, but I have to write something.
Put the number back in.
Set the
Make
equation
that
equal to
minus
zero.
Right.
equal-
Every time I find the x-intercept, I have to set y equal to 0. And y is the whole thing. Negative x squared minus 6x minus 8 equals 0. You're on the right track, Damon. You're correct. Okay, so then, how do I solve this? We shouldn't be thinking that much, that long.
You gotta solve it.
How? Yes, but I refuse with a negative leading coefficient. I refuse to do it. What should I do? It's not cleaned up, by my standards anyway. What should I, say it again? No. I mean, I could, yes, I will factor, but it's not cleaned up yet.
Can you move everything to the other side?
Or multiply both sides by -1. I refuse to solve a quadratic equation with a negative leading coefficient. You will never force me to do that because I won't. It's too complicated. Too many negatives. I could make a very simple mistake any moment. So I get x squared plus 6x plus 8 equals 0. And yes, I will factor or quadratic formula, whatever you want. But I refuse to solve, and you can write this down. I refuse to solve a quadratic equation with a negative leading coefficient forever. So now,
X plus 2, X plus 1.
so the two options are awesome. So what are the ordered pairs that are the x-intercepts? Never. That's, that's okay. Step number 4, 5, and 6. And 7, you already told me 7, I'm going to write it. Negative infinity to 1. In step number 4, the y-intercept. That will always exist. So how do I get it? For any function, how do I get the y-intercept? Very good. So I have to find f of 0. So let's take a look. That was a long time ago. I'm not going to plug in 0 here and here, right?
-8.
Is that clear? Why it's -8? Very good. And what is the ordered pair? Awesome. 5 and 6 are words, but they're very important. You already told me, I'm going to write it. Max value of f of x is, and please give it to me again, 1. Very good. And number 5 is the axis of symmetry. We're not talking about odd or even. This is a totally different thing here. So parabola is a symmetric figure, symmetric graph with respect to the vertical line passing through the vertex. So this is the maximum. This side is a mirror image of this side with respect to the axis of symmetry. Same thing here. This side and this side are symmetric with respect to this line. Same thing here. So knowing that the vertex is, what was it, -3, comma 1, can anyone give us the vertical line? This is -3, comma 1. The vertical line passing through -3, comma 1.
That's -3.
X equals -3. Perfect. Indeed. We're done. Let's graph it. We start with the vertex. Bless you.
Let's say y-intercept.
Yes.
Okay, thank you.
The vertex. -3, 1. 1, 2, 3, 1. I continue with the axis of symmetry. It's not a solid line. It will just help me keep the graph in shape. The x-intercepts, you gave me -2, 0, and -4, 0. You understand that if I find that the x-intercepts are 1 and -4, something is terribly wrong. Because they have to be symmetric. They have to be 1 unit or 2 units or equidistant from the axis of symmetry, correct? So if this is -3 and this is -2 and this is -4, that's okay. And then you said 0, -8 for the y-intercept. Okay. I will try to make it as symmetric as possible and not too acute at the vertex. I always write the function. I graphed this. Any questions? Any questions for me? Any questions?